Alright, so in this video we're going to be doing a little bit of a tutorial on how to do dimensional analysis. Alright, so before we get into actual chemistry examples, I wanted to go ahead and do more of a real life example just so you understand the importance of dimensional analysis and so you kind of get the gist of it. Alright, so right here we're going to be pretending that we're having a pizza party, right? And we're going to calculate how many boxes of pizza we need. Alright, because we don't want to purchase too much because we're not rich, and we don't want to purchase not enough because then our party is going to stink because everyone's going to be hangry, right? So we have 20 guests as outlined over here on the right. Each person is going to want three slices of pizza, and each box comes with 8 pizza slices. So now we have to calculate how many pizza boxes should we order so that we get the right amount. All right, so let's go ahead and start off over here. 20 people, right? Now, let's see if my dimensional analysis is correct. But we're going to go ahead and put one people. I'm going to keep people as the same just so we don't get confused with that instead of changing it to person. It's going to want 3 slices, right? Now over here, one box contains 8 slices of pizza. Alright, so now let's go ahead and calculate this. So 20 divided by 3 divided by 8 is equal to 0.833. Right? So let's go ahead and look at our units. So all the engineering majors should know this, maybe some science people too. But whenever you have units multiplying by each other, they actually become squared. So our units here are going to be people squared times boxes of pizza divided by slices squared. So let's say you tell your friends to go buy the pizza, and let's say you tell them, okay, dude, I need you to buy 0.83 people squared times boxes divided by slices squared. He's probably gonna have no idea at all what you're talking about, right? Because this makes absolutely no sense. Okay, neither is the Domino's guy who takes your order. He's gonna be, okay, what is people squared times boxes divided by slices squared? All right, this is just an example of how we messed up our dimensional analysis, right? So let's go ahead and do this the correct way. Okay, so obviously our final answer, we should be looking at our final answer and kind of thinking to ourselves, what units do we want to end up with? Well, obviously we can only buy pizzas by the box, right? So we want to try to cancel out our units so that the final answer has the units of just boxes of pizza, right? So we can tell our friend, okay, go buy X amount of boxes, or go buy whatever, right? So 20 people times, and we're going to go ahead and put 1 people on the bottom so that people can cancel out, and we're going to put 3 slices per person on the top, right? So people over people cancel out to 1, right? So now we have slices. Are we done? No, we still need boxes of pizza, right? So we're going to go ahead and put the conversion factor for boxes on the next step, right? So 8 slices of pizza per every 1 box of pizza. So slices will cancel out slices, so that equals 1, and we're left with boxes of pizza, which is exactly what we wanted. So let's go ahead and do this calculation. 20 times 3 is 60. Divided by 8 gives us 7.5 boxes of pizza. So we told our friend, okay, I need to go buy 7.5 boxes. Well, obviously you would have to ask for 8, right? So if you told our friend, okay, go buy 8 boxes of pizza, and that'll cover our party, right? He'll know what you're talking about, right? So will the Domino's guy, and so will everyone else, right? 8 boxes of pizza makes sense, not people squared times boxes divided by slices squared, right? So that kind of just highlights the importance of dimensional analysis and how messing it up can severely impact your answer. Because obviously 8 and 0.83 are 2 completely different things, not even close to being the same. And if this was for whatever reason an exam question, 0.83 wouldn't be considered anywhere close to 8, and you would get 0 partial credit, right? Okay, so let's go and look at a more realistic question of what you'll see in the chemistry class. Alright, so let's go ahead and do some unit conversions here. So let's go ahead and start off with, let's say we start off with, we want to know how many picograms there are in a kilogram, right? So that's an easy example, right? So in 1 kilogram equals how many picograms, right? So it's fairly simple. You start off by putting the conversion factor. So we're going to put 1 times 10 to the 3 grams. Actually, I should start off with kilograms because that might confuse some students. Alright, so 1 kilogram, right? What I like to do, just so I don't mess myself up with subtracting and adding exponents, I always just try to convert to the base value. Alright, so just the regular gram, which is down here. Alright, so hopefully you know just by experience that there's 1,000 grams in 1 kilogram, right? So what we're going to do is we're going to put 1 times 10 to the 3 grams is equal to 1 kilogram. And if you notice over here, it says a kilogram is 1 times 10 to the 3. Notice that that applies to the gram, not anything else. Alright, there's not 1,000 kilograms in a kilogram, right? There's 1,000 grams in a kilogram. Okay? And actually, I messed that up. Sorry about that. 1 times 10 to the 3 grams is equal to 1 kilogram. Right? I was about to end up with people squared times boxes over slices squared, but I caught myself. Okay? So now that we're in the gram, we go to the picogram. Okay, so in 1 gram, we're going to find 1 times 10 to the negative 12, or 1 times 10 to the 12 picograms. Alright? Notice how I changed the sign there. Alright? I changed the sign because, let's see. Okay, so think of it this way. A picogram is obviously a very, very, very small thing, right? And a gram is fairly, it's a recognizable amount. If I told you, okay, here's a picogram of gold, and I handed it to you, I would pretty much hand you nothing, right? It's really, really small, really small amounts, and it's almost unrecognizable, right? So just think to yourself when you do these calculations, okay, does what I'm doing make sense? Because if we were to put 1 times 10 to the negative 12 picogram in 1 gram, we're saying that a picogram is an enormously large amount, right? So for example, when you say here's 0.01 of a dollar, that means that you're giving someone a cent, right? But if you were to tell them that a cent is or that a dollar is 0.01 of a cent, you're saying that a cent is 10 times or 100 times larger than a dollar, which makes absolutely no sense, right? So think of it to yourself always like that. Okay, so we're going to go and put 1 times 10 to the 12 up there. And once you multiply all that out, you end up with 1 times 10 to the 15 picograms in 1 kilogram. Right, which is obviously a very, very large number. Okay, so let's do a little bit more of conversions here. Okay, so we're going to figure out how many. Okay, so let's say we have 2 megagrams, and we're going to try and convert that into, let's say, gigagrams, right? So let's see, in 1 megagram, let's go and convert back down all the way to grams. There's going to be 1 times 10 to the 6 grams, right? Because a megagram is obviously very, very large, and it's much larger than a gram, right? So now that we're in the gram, let's go to convert into the teragram. So in 1 teragram, so let's go and put 1 gram. Actually, let's do it this way. In 1 times 10 to the 12 grams, there's 1 teragram. You could also do it the opposite way, in which you would put, let's go ahead and copy all that down here, times, in 1 gram, there's 1 times 10 to the negative 12 teragrams. Either way is perfectly fine, and they're both valid mathematical operations, right? If you recall from algebra or pre-cal or calculus, wherever you might have learned this, um, if you move an exponent from the denominator to numerator, you change the sign, and vice versa. If it was, for example, right here we have 10 to the negative 12 on the numerator. If we were to move that to the denominator, we would have 1 times 10 to the 12 grams, right? So they're both the exact same thing. They'll give you the exact same answer, right? So right here, in 2 megagrams, we have 2 times 10 to the negative 6 teragrams, right? And notice that our units cancel out here. Megagrams cancel out megagrams, grams cancel out grams, and we're left with teragrams, which is exactly what we wanted. All right. So let's do one final one. So let's say in 100 centigrams, let's calculate how many milligrams there are, right? So let's convert back down all the way to the gram. So in 100 centigrams, actually let me use scientific notation. In 1 times 10 to the negative 2 centigrams, or actually to the positive 2, right? There is 1 gram, right? So now let's go ahead and convert into the milligram now. So in 1 gram, there is 1 times 10 to the 3 milligrams, right? And that gets us to an answer choice of 100 times 10 to the 1, which, when you convert that to scientific notation, is 1.00 times 10 to the 3 milligrams in 100 centigrams, right? So hopefully you found that helpful. If you have any other questions, you could go in and ask your peer leader or your professor. Thanks for watching.